So yesterday we looked at adding and subtracting polynomials. We saw that you can only add and subtract like terms. Like terms are terms that have the same variables with the same exponents. And we also saw that when you add and subtract those like terms, the powers don't change. But when you multiply and divide polynomials, the powers sometimes do change. We saw also yesterday that the quotient law for exponents said that if you divide powers with the same base, you subtract the exponents and keep the base the same. So we're doing some of that. And when you multiply powers with the same base, you add the exponents and keep the base the same. So we'll be doing some of that as well. So first we'll start out by multiplying x by 2x plus 3. And you can do this a couple different ways. One of them is a area model, where each term is written as a second part or separate part. So you're multiplying x, which we have the x down here on the left, and that x is being multiplied by 2x and a positive 3. So the first space at the top is for the 2x, the second space is for the positive 3. And then you're going to multiply the 2x by the 1x. And when you multiply polynomials, normally we do this in steps, which means multiply the coefficients first. 1 times 2 is 2. And when you multiply the x's together, you have to remember that you add the exponents and keep the base the same. The power on both of these x's is 1. 1 plus 1 is 2. So we'll get 2x squared. And then when you multiply the 3 by the 1x, it's 1 times 3, which is 3. And because this x is not being multiplied by any x here, it doesn't change. It stays 3x. So that gives us an answer of 2x squared. And then we need a sign in between the 2x squared and the 3x. And because that 3 is a positive 3, it's a plus 3x. So that's what you get when you multiply out using the area model. And you may have learned about algebra tiles. Algebra tiles are used to represent different terms. You may have learned that the skinny rectangular tiles represent x tiles, and the colored ones are positive. If they're blank, they're negative. The small squares represent positive ones. So you can see this is a 1x, and a second x gives our 2x's, and then plus 1, 2, 3, there's your plus 3. This one on the side is a positive x. And then to fill in the space, we draw tiles that have the same width as what's above, the same height as on its side. And because it's a positive times a positive, this is a positive as well. So this is my sad attempt of coloring that one in. But the big squares represent x squareds. That is found by measuring an x by an x. That gives you an x squared. So the large squares are x squareds. And for the second space, it's the same. You draw a tile that's the same width as above, Brock. Put your phone away. And the same height as what's on its side. And again, it's a big square, and we multiply a positive times a positive, which gives us a positive, which is why I'm coloring that in. The next space will be filled in with a tile that's the same width as what's above, the same height as what's beside, and that's a positive 1x. And these next two will be the same width as what's above, same height as what's on its side, which gives us positive 1x's. So we have 1x squared plus another x squared, which is a 2x squared, and then positive 3x's gives us our plus 3x. So that's using an algebra tiles. So you have those options, but normally we're going to do these using the distributive property, which means you're going to multiply everything inside the bracket by what's in front, step by step. So first we'll multiply the x by the 2x, so that is a 1x. Again, multiply coefficients first. 1 times 2 is 2. And when you multiply x to the 1 by x to the 1, add the exponents. 1 plus 1 is 2. Keep the same base. And then when you multiply the 1x by the 3, 1 times 3 is positive 3. This x is not multiplied by any x here, so it doesn't change. So using the distributive property, 2x squared plus 3x. And this is how we're going to do it. The other ways work, but they take a little bit more room and time. Distributive property is what we're going to use just to save time. but they will all work. So on the next page, we want to simplify each of the following, which means multiply them out in this case. The 2 in front is multiplied by all 3 terms inside the bracket. And because there is no x on this 2, none of the x's are going to change. You're just going to multiply the coefficients. The coefficient in front of the x squared is a 1, so it's 2 times 1, which is 2, x squared. And then 2 times negative 3 is negative 6, x. Again, the x's don't change because there's no x with the 2. And then finally, 2 times positive 9 is positive 18, and there's your answer. That's the product. For question B, using distributive property, every term inside is multiplied by the 3m outside. Coefficients first. 3 times 5 is 15, and now we're multiplying the m's inside by an m to the 1. And you remember when you multiply powers with the same base, you add the exponents. Keep the base the same. 1 plus 2 is 3, so it becomes m cubed. 3 times positive 3 is positive 9. M to the 1 times m to the 1, add the exponents. Gives you m squared. 3 times negative 7 is negative 21, and then this m is not multiplied by any m on the 7, so that means the power doesn't change. So there's your answer. Okay, for the next one, 2 terms, there's a binomial inside the bracket, both terms multiplied by the 4a squared in front. 4 times 5 is 20, and a squared times a cubed, add the exponents, keep the base the same. 4 times negative 8 is negative 32, a squared times a squared, add the exponents, keep the base the same, you'll get a to the 4th. There's the answer. Question D, you've got 4 terms inside the bracket that will all be multiplied by the negative 6y in front. So Keen, you should have your package out and checking it, making sure that you got what I get. So coefficients first, negative 6 times 3 is negative 18. Y to the 1 times y to the 4th, add the exponents. Negative 6 times 7 is negative 42. Y to the 1 times y squared, add the exponents. Negative 6 times negative 9 is positive 54. When you multiply the y's together, add the exponents. 1 plus 1 is 2. Negative 6 times negative 2 is positive 12. Y. There is no y on that 2, so the y on the negative 6 doesn't change. Do those next 2 on your own, then we'll check them. So for that first one, all 3 terms inside the brackets multiply by 3n squared in front. Coefficients first, 3 times 2 is 6. N squared times n to the 4th, add the exponents. 3 times negative 7 is negative 21. When you multiply the n's together, add the exponents. 2 plus 3 is 5. 3 times 3 is positive 9, and then the n squared is not multiplied by any n, so the power doesn't change. There's the answer. And then for B, all 3 terms inside the bracket are multiplied by negative 3x in front. This x squared is 1x squared, so negative 3 times 1 is negative 3. When you multiply the x's, add the exponents. 1 plus 2 is 3. Negative 3 times negative 8 is positive 24. X to the 1 times x to the 1, add the exponents. Negative 3 times negative 10 is positive 30, and then that x is not multiplied by any x's, so it doesn't change. There's the answer. So now we'll get into solving some equations. What does it mean to solve the equation 2x minus 5 equals 7? Well, what that means is you want to find the value of x that makes that equation true, that makes it work, so that the left side and the right side are the same. So if you look at something like x plus 3 equaling 5, you can think of it as a balanced scale. The equal sign means the two sides are equal. So whatever x is, it has to make it so that the balanced scale stays equal. And on the left, we have 3 balls plus an x. On the right, there's 5 balls altogether. So the x would have to be 2 more balls so that you get 5 balls on each side and the balance is kept. So how do you isolate the variable in an addition equation? Well, what we always do is you always do the opposite operation. If you have x plus 3 equals 5, and you want to get x by itself, that means getting the variable isolated. That wasn't very nice. How would you like it if I started throwing things at you? You wouldn't care. What if it escalated to hitting and kicking? Then you would. You'd call the principal on me. I'm not afraid of him. Okay, so we want to isolate the variable. You want to get x by itself. So you got to look and see what's hooked onto the x and by what operation. The x and the 3 are hooked together by addition. The opposite of adding 3 is what, Keen? Subtracting 3. And whenever you do to one side, you have to do the same thing to the other. Otherwise, it throws it out of balance. And on the left side, the 3 take away 3 cancels. And so you're just left with x on the left, and on the right side, 5 take away 3 is 2. And if you do it right, it works every time. Whatever you do to one side, you do the same thing to the other. You look and see what's hooked onto the variable and by what operation. You always do the opposite. Okay? So the first one, it says solve each of the following equations and verify our solution. So we're going to check them. That's what that means. Verifying it means to check. So we will do that with all of these questions. And on a quiz or a test, if you're solving equations, the expectation will be that you check it as well. So for that first one, we want to get the variable x by itself. Hooked onto the x is a 7, and it's hooked on there by a plus. The opposite of adding 7 is subtracting 7. So what do we do, Jensen? Who? I asked you what your middle name is. That's why you need to pay attention. We're on question A. What do we do? Should I ask Jan? Jan?
We subtract 7 on both sides.
Yeah, subtract 7 on both sides. Because the x and the 7 are hooked together by addition. So the opposite of adding 7 is subtracting 7. And you have to do the same thing to both sides to keep it in balance. So on the left, 7 take away 7 cancels. That's why we did that. We now have x by itself. And on the right, 10 take away 7 is 3. And so no matter how obvious it seems, if you're asked to check, you need to do that. You need to show that you get the same value on both sides when in this case x equals 3. So on the left, x is 3, and 3 plus 7 does equal 10. This is a proper check, showing that you get the same thing on both sides when you let x equal positive 3. Question B, Sal, what do we do? You agree with that, Brody? Yes, because the y and the 15 are hooked together by addition. The opposite of adding 15 is subtracting 15. And whatever you do to one side, you must do the same thing to the other. So the whole reason we did that is because on the left, the 15s cancel, and you're left with the variable y. And on the right, 26 take away 15 is 11. So that should be our answer. That's the number that we need to use in our check to make sure that it works. So y is 11, and 11 plus 15 does equal 26. We get the same thing on both sides, so that shows that it works. Okay, shows that it works. Brooklyn, what do we do for the next one? Right, because the m and the 8 are hooked together by addition. Even though it's the 8 first, the m second, that is a positive 8. So the opposite of adding 8 is subtracting 8. And whatever you do to one side, you must do the same thing to the other. So on the left, 8 minus 8 cancels. You're left with the letter m. And on the right side, 14 take away 8 is 6. So there is your answer that you would use in the check. So again, we start by writing the original equation. And on the left, 8 plus 6, there you go, is 14. So you get the same thing on both sides. So that's our check. It shows us that our answer is correct. It works. If you have a subtraction equation, that means you're going to add the same number to both sides. Again, you look and see how things are hooked together. You do the opposite operation. So to get rid of the minus 5, we have to do the opposite of subtracting 5, which is adding 5 to both sides. On the left, minus 5 plus 5 cancels. We're left with the letter A. And on the right, 14 plus 5 is 19. There's our answer. That's what we have to use in our check to make sure that our answer is correct. So again, the equal sign divides the equation into two sides, the left and the right. That's why I always put the line down below the equal sign. That's where it divides it into two sides. We've got 14 on the right side. We need to get 14 on the left side when we let A equal 19, and we do. 19 take away 5 is 14. So we just checked our answer. It works. Okay? Declan, what do we do for question B? To both sides. Whenever you do to one side, you must do the same thing to the other. So on the left side, minus 9 plus 9 cancels. You're left with x. And on the right, negative 4 plus 9 is positive 5. So there's our answer that we need to use in our check. On the left, 5 take away 9 is negative 4, so it checks. Right? Question C, Cherry, what do we do? Okay, so how are we going to get the n by itself? How do we get rid of the minus 8? Add 8. And whatever you do to one side, you must do the same thing to the other, so we need to add 8 to both sides. So minus 8 plus 8 cancels, and you're left with n by itself on the left, and on the right, negative 12 plus 8 is negative 4. And if you need to use your calculator to help you with these integers, then do that. It's no problem. But the answer is negative 4, and I'll do the check just below. N take away 8 must equal negative 12. Again, the equal sign divides it into two sides. The right side is negative 12. We need to get negative 12 on the left side as well when n is negative 4. And negative 4 take away 8 is negative 12. So it checks. So looking at these questions below, what do we do for question A, Ava? You agree with that, Liam? Yes. The h and the 7 are hooked together by addition, so we do the opposite, which is subtracting. 7 from both sides. So 7 take away 7 is 0. They cancel. You're left with h. And on the right, 10 take away 7 is 3. So we're saying that's our answer. If I do the check below here, the right side is 10. On the left side, I'll have 3 plus 7, which also equals 10, so it checks. Get the same thing on both sides. That tells you that your answer is correct. Question B, Jensen, what do we do? Add 9 to both sides. Agree with that, Kenzie? Yes. The opposite of subtracting 9 is adding 9. This is how you get the variable a by itself. On the left, minus 9 plus 9 cancels. You're left with a. And on the right, 41 and 9 gives us 50. So there's the answer that we need to put in our check. Again, your check starts with the original equation, always. Equal sign divides it into two sides. The right side is 41. We need to get 41 on the left as well when you let A equal 9. And you do. So the answer checks. What do we do for the next one, Keen? Sorry? He says subtract 10 from both sides. You agree with that, Brooklyn Lorenz? Yes. That is a positive 10. So you have to do the opposite of plus 10, which is minus 10 on both sides. So on the left side, 10 minus 10 cancels. You have x by itself. And on the right side, 17 take away 10 is positive 7. So we're saying that's our answer. So that's what we'll put in our check. The right side is 17. We need to get 17 on the left side, which we will get. 10 plus 7 is 17. So it checks. Question D, Emil, what do we do first? Add 14 to both sides. And the reason we do that is on the left, 9 is 14 plus 14 cancels. You have D by itself. And on the right, 6 and 14 added together gives us 20. So there's our answer. That's the number that we need to use in our check. Again, the equal sign divides it into two sides. The right side is 6. We need to get 6 on the left as well when D equals 20, and 20 minus 14 is 6. So it checks. We've just shown that our answer is correct. Stanley, what do you do for the next one? Why are you adding 2 to both sides? Say again? Yeah, because the opposite of a negative 2 is a plus 2. That is a negative 2. It doesn't matter if there's a plus sign in between them. That's a negative 2. The only way you can get rid of a minus 2 is by adding 2 to both sides. That's how we isolate the variable. On the left, negative 2 plus 2 cancels. You're left with m. And on the right, negative 6 plus 2 is negative 4. So there's our answer, and that's what we need to use in our check. Again, start with the original equation. So negative 2 plus m, which we found to be negative 4, does equal negative 6, so it checks. We've just shown that our answer is correct. Peyton, what do we do for question F? You agree with that, Sophia? Yes. To get the p by itself, you have to get rid of the minus 32 by adding 32 to both sides. So on the left, negative 32 plus 32 cancels. That's why we added 32. We've got p by itself. And on the right, negative 11 plus 32 is positive 12. Sorry, positive 22. So there's our answer, and that's what we need to use in our 21, I'm sorry. I messed that up again. There we go. So p minus 32 equals negative 11. And 21 take away 32 is negative 11, so it checks. We've just shown that our answer is correct. Okay? All right. So we'll do some more equations next class on Monday. We've only got a few more days of this review, and then we're going to start the actual Math 10C course. So I'll hand out the assignment. I encourage you to do it. Check your answers on Google Classroom because I'll post the solutions there. There's also a few of you that missed that